All right, welcome back, everybody. We have another installment of Mr. K's pretty awesome math videos. Today we're going to be looking at Chapter 2, Section 1, where we go over conditional statements. Now, really the three big things you really want to focus on in this section are understanding, one, how to write conditional statements using the if-then form, being able to identify what the hypothesis and conclusion are of a conditional statement, really being able to write the converse of the conditional statement, and then being able to determine if a biconditional statement can be written. Now, we've touched on inverses and contrapositives during our lesson. Those will not be a large part of what we work with, but it's always helpful to know more. The more you know, the better you are. So, we're going to have a short little video today. We're not going to spend too much time on this. If you need more practice or want more practice, I strongly suggest you go to your textbook, page 71, and just do some of the practice problems. Do any of the odd ones. The answers are in the back of the book. And if you want to do the even ones and bring it into me and I'll check your answers and tell you how you're doing, you can do that as well. But that would be a great way for you to just really kind of shore up your familiarity with these concepts. So, let's start with the statement. The measures of complementary angles sum to 90 degrees. We know that to be true. It's the definition of complementary angles. Notice it is not in conditional statement form. It's not written as a conditional statement. It is not in if-then form. So let's first write it in if-then form. Now, some statements, they might seem a little bit vague as to what the hypothesis would be and what the conclusion would be. This is kind of one of them. It might work both ways. So let's just go ahead and say, all right, the kind of beginning portion, that's going to be our hypothesis. The second portion is going to be our conclusion. So we can say the measures of complementary angles. All right. Complementary angles would be our hypothesis. And the conclusion, will be that they sum to 90. So, a conditional statement is written in the form if P, then Q. Where all P and Q are variables that represent different parts of the statement. The variable P represents the hypothesis of a conditional statement, and Q represents the conclusion of a conditional statement. So, we have if. Okay, our hypothesis had to do with complementary angles. Now, sometimes you might have to reword things a little bit. Maybe add a word, restructure the phrasing so it makes sense and flows. So let's say that if two angles are complementary, then, actually let's go ahead and put the then down here. Then, my conclusion their measures sum to 90 degrees. So notice how what I had underlined in the original statement is not exactly what you see in the conditional statement. It's slightly restructured, but the core concept of those parts are the same. The hypothesis has to do with angles being complementary. The conclusion has to do with their measures adding up to 90 degrees. So, that is our conditional statement. If P, then Q. The converse of a conditional statement just switches that hypothesis and conclusion. So now it'll be if Q, then P. And I'll keep the colors the same. So pink will go with complementary, orange will stick with 90 degrees. So now if, we're going to switch these two. If the measures of two angles sum to 90 degrees. Again, notice how it's slightly changed. Then if the measures of two angles sum to 90 degrees, then they are complementary angles. Okay. So notice now the two parts have just switched. Moving on, I'm going to quickly touch on inverse and contrapositives, and then we're going to kind of forget about it for a while. So, the inverse just takes whatever the converse is and negates the hypothesis and the conclusion. So, we have if not P, then not Q. Okay, that's the inverse. It negates the hypothesis and the conclusion of the conditional statement. Try to keep track of the order of what we're working with here. Conditional, converse, inverse. It's going to be the same as your notes. So, now let's go ahead and do this. Okay? So we go back to the regular conditional and we just negate the hypothesis and conclusion. So where's my pink marker? Here we go. If two angles are not complementary, then orange. Here we go. Got a lot of markers. Then their measures do not sum to 90 degrees. If two angles are not complementary, then their measures do not sum to 90 degrees. Do you see how we have just negated the original hypothesis and negated the original conclusion? That's what the inverse does. Lastly, the contrapositive, instead of negating the conditional statement, it negates the hypothesis and conclusion of the converse. So, we have if, let's put all these down, if not Q, then not P. Okay, so last one. All right, here we go. So now we're going back to the converse, and we're negating the hypothesis of the converse and the conclusion of the converse. So, if the measures of two angles do not sum to 90 degrees, if the measures of two angles don't sum to 90 degrees, then, there's my pink for my go, then they are, oops, here's my red for negating it. Uh-oh, where'd my red marker go? Oh, it's in my hand. Then they are not complementary. Okay. So we'll go through all this once more. Hopefully that is legible. Slide it in a little bit. There we go. All right. So we take a regular statement. We identify a hypothesis and a conclusion. Okay? One part has to depend on the other. The conclusion depends on the hypothesis. So, the conditional statement is in the form of if P, then Q, where P is just whatever the hypothesis is, Q, whatever the conclusion is. Now, sometimes we have to reword these a little bit. So, our conditional statement here is if two angles are complementary, then their measures sum to 90 degrees. The converse takes that hypothesis and conclusion and switches them. So the converse would be if the measures of two angles sum to 90 degrees, then they are complementary angles. The inverse takes the hypothesis and the conclusion of the conditional statement and just negates it. If not P, then not Q. If two angles are not complementary, then their measures do not sum to 90 degrees. And lastly, the contrapositive negates the hypothesis of the converse and the conclusion of the converse. Okay? So, if the measures of the angles do not sum to 90 degrees, then they are not complementary. Now, one skill that you guys really should be able to get, accumulate or ascertain is the ability to determine if a statement is true or not. Now, in this case right here, all of these are going to be true. If two angles are complementary, then their measures sum to 90 degrees. That is true. If the measures of two angles sum to 90 degrees, then they are complementary angles. That is true. If two angles are not complementary, then their measures do not sum to 90 degrees. That is true. And lastly, if the measures of two angles don't sum to 90 degrees, then they are not complementary. Again, that is true. Okay, so you should be able to analyze these statements and say whether they are true or not. Okay, now, to wrap it up, we're going to quickly look at what biconditional statements are. So what I'm going to do real quick is I'm going to go ahead and erase all of our inverse and contrapositive stuff. Okay? All right. Now, if you were paying attention, you hopefully realized that we just said that both of the conditional statement and the converse were both true. When those two types of statements are both true, we can then write one single statement. And that single statement is called a biconditional statement. Bi is your little prefix for to. Okay? So what the biconditional does, it takes our hypothesis and it takes our conclusion and it allows us to have one infer the other and other infer the one, if that makes sense. We'll have to go back and forth in terms of what we're inferring. Oh, sorry, I got a little phone call. Hey, babe. Hi. How's it going? Yeah. No, that's fine. I'm just doing a math video right now. Yeah, literally as we speak. Yeah, it's okay. Do you want to say hi to the students? Okay. Is it cold? No, it's not cold in here. It's freezing. Oh, okay. All right. Okay. All right. Love you too. Bye. All right. There we go. All right. Sorry about that, guys. So, biconditionals. Here we go. So what we're going to do is we're going to take these statements and we're going to write just one. Now, what this statement does is it drops, it gets rid of the if and the then of the conditional statement. And what we do is we put a different phrase right in the middle. We put a phrase of if and only if. So, we have our hypothesis. Two angles are complementary. Hopefully I can fit this in. Two angles are complementary if and only if their measures sum to 90 degrees. Notice the lack of the word if in front. A lot of you, if you are unable to drop that word if, you will have a very hard time vocalizing that biconditional statement. You have to remember there's no if at the beginning anymore. It's just the hypothesis, if and only if, the conclusion. All right, so that wraps up section 2.1. Again, guys, this stuff, it's really not that difficult. It just takes practice, as everything else does. So go ahead and go to page 71 in your textbooks and just do some practice, okay? Do the odds, check your answers, do the evens, and come to me and I'll check them with you. All right? Tune in very soon and we will be going over section 2.2. Have a good night.